Hello friends, Eli Hibit here with the Pwn Your Homework Physics Series podcast. If you're looking to prepare, review, or gain an added edge or point of view about topics in physics, then look no further. Tune in each week to unlock your understanding of the physical world surrounding us. And now let's dive right in. Hey, how is everybody feeling today? I am your host Eli Hibit, back at you with another episode of the Pwn Your Homework Physics Series podcast. And today we have the thrilling conclusion of the Physics Brushup series, Physics Brushup Volume 3, episode number 82. So, yeah, how you been doing? I've been doing good, gearing up for Christmas. Here, in America, I know a lot of people listen worldwide, but here we are knee-deep into the Christmas season, and so taking a lot of our time, but other than that, things are going good. Let's take a look in the sky and see how the moon's treating us. Open up my trusty moon app here. Oh, 84% illumination, waxing gibbous. We got a new moon coming up in 19 days and a full moon, Christmas Eve, 3 days away. So I figured I would wrap up this physics brush-up review and give you a little taste of where we're going in the future. But actually, this whole episode is in the future. None of this stuff has been covered on the show yet. Today, we're going to do lines and linear equations and parabolas and quadratic equations, calculus, kinematics, and force. So, a little soupçon of things coming in the future. And then we'll talk a little bit about where we're going in the next 15 to 20 episodes and go from there. So, all right, let's first do a little quiz about lines, linear equations, and relationships of that ilk. So these are questions that you will not be able to answer if you're only going off this podcast, but you should, definitely listen and kind of, start to, let this information percolate into your system. And if you should know it, you should know this stuff. So let's dig in. Lines and linear equations. Many physical systems follow linear and parabolic relationships, and that's kind of why it's important to know this stuff when you're digging into physics. So 2 questions. First, which property of a linear system controls the steepness of the line? And that would be the slope. Changing in slope changes the steepness or slope of the line. And what is the highest order in a parabolic or quadratic equation? Parabolas are quadratic equations, described by quadratic equations, and the highest order is 2. It's x squared equation. So, y equals x squared gives you a parabola without anything else. So that's lines and linear equations. Let's go into calculus. Of course, if you are in physics, you are probably also in calc of some sort. And so, you should know this stuff as, like the back of your hand. These questions are very softball calculus questions, but let's dive in. What is the derivative of x squared? Derivative of x squared is 2x. Take the exponent and make it the coefficient and then subtract the exponent by 1. So it's 2 times x to the first. Next question. What is the derivative of sine? Trig function again, rearing its ugly head. Derivative of a sine is cosine. And what is the integral of x cubed? Last question. So, kind of derivative and integrals being opposites in some sense. What we do here is increase the exponent by 1 and then divide by that number. So the integral of x cubed is x to the 4th divided by 4 plus c, that constant that you're going to have to solve for based on your exact, set of boundary conditions. So that's calculus. Let's dig a little bit into kinematics and kinematic equations. If you were taking physics this semester, you definitely probably know this stuff, rather intermittently. So here we go. 3-question kinematic pop quiz. What is the quantity represented by V0 or V0 or VI? This represents the initial velocity of the objects traveling in your system. What is the quantity represented by XF? In kinematics, XF represents the final position. If you're looking at, just one direction, and if you're in 2 dimensions, up and down and left and right, then XF represents your final position in the X direction. Lastly, what is the quantity represented by T? T, I think I mean, the answer to this question, T is time. But it's pretty much time all the time, unless you're dealing with thermodynamics, and then T is temperature. But that's pretty much it. A lot of other variables have many different meanings depending on what exact topic you're focusing on. But T is usually time, pretty much across the board. So that's a little kinematic brush up. And force. Here we go. F equals ma. 3 questions about force and force equations. Which law gives the popular equation F equals ma? That would be Newton's laws of force, and that's Newton's second law, is pretty much the sum of the force is equal to the mass times acceleration. F equals ma. Sigma F equals ma even. Question number 2. What is the name of the force which always points perpendicular to the surface on which an object rests? This is the force that you never really think about, but is always there, is referred to as the normal force. And it's the force that opposes your motion from, falling into the earth. Question number 3. How do you line up a force with a coordinate axis if it's not already lined up? This question you would be able to gather from previous episodes of this podcast, I think. So if we have a force, which is a vector pointing in a direction which is not parallel with a coordinate axis, then you will have to break it into components and make those force components line up with your coordinate axis, which you'll be doing over and over and over again when we dive into Newton's second law. So that is a very good indication of where we're going. A little preview of the next 15 episodes or so. So the plan is to wrap up vectors and cross products. Then we're going to do lines, linear equations, quadratic equations, and parabolas. A little bit of calculus. And that is going to wrap up. That should bring us right to episode number 100. And then I will, the first 100 episodes, I think, are the physics boot camp. And so with that, under our belts, we will be pushing forward with, we'll start with kinematics and force and go from there. And we'll be diving into all kinds of topics. But they'll actually be, we'll be able to take the tools that we learned in the first 100 episodes and then press forward and use those tools. So we are coming right up on it. But actually, this is episode number 82, and for episode number 83, since it's Christmas, we're going to be taking a look at a little introduction to series and parallel circuits in the form of Christmas lights. I had the distinct pleasure of putting on my Christmas lights this year and having strands go out left and right, and so I thought maybe that's a good way to think about circuitry and electronic circuits, which is definitely something that they cover in first year physics. So that's where we're going next episode, and it should be up way before Christmas. And so yeah, that's gonna be it for this week. Physics Brush Up volume number 3. So we finished the whole Brush Up series here. I do have a Physics Brush Up app bundle for you, $7.99, and goes through pretty much everything except the kinematics and force. I have a Kinematics app and a force app. The force app is great. It gives you a step-by-step on how to do any free body diagram problem and gives you several examples and flashcards. The Kinematics app is very unique. And what it does is it gives you a checklist and allows you to interactively tap through with all the kinematic equations and cancel out variables and show you which equation to use, which is a really, really, really helpful tool, but something we haven't exactly covered here. So if you're interested in any of that, go over to pwnyouRHW.blogspot.com and check out the apps, because they are really, 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 really cool. And with that, I think, thanks everybody for a wonderful year. And I'll be coming at you with a little bit of Christmas, and then we're going to be digging in for gearing up for episode 100 and finishing up the boot camp section of physics so we can actually dive into physics. So with that, hope you did well this semester, and if it's not over yet, best of luck, friends. So with that, stay frosty, stay in the zone, and I'll catch you next time, guys. Take care.